Hello, thank you for joining me here. This is Twitter Think. Before I start, I have seen that about 76% of my viewers have not subscribed to this channel. I would be glad if you support this work by subscribing to this channel. Click on the notification button for more updates. Please, in this video, I will be talking about introduction to Laplace transformation. So I have written down a definition here that the Laplace transformation of a function, or the Laplace transform of a function f of t, is denoted by L f of t, which is the Laplace transform of f of t, and defined as the integral of f of t times e, or the exponential function to the power negative st, between the limit t equal to 0 and t equal to infinity. Alright, so from the formula that we have here, we have the Laplace transform f of t, or you can denote this by f of s, that is why I've written it here, equal to the integral of the lower limit, which is 0, and the upper limit, which is infinity, and then times f of t times what? E negative s of t. So the s that we are seeing here is a positive constant that is large enough to ensure that the product of f of t and e negative s of t will converge to 0 as t approaches infinity. Remember that we are taking the value between what? T equal to 0 and t equal to infinity. This means that t should be greater or equal to 0. So t here is a real number that must be greater or equal to 0. Alright, so let me break this definition down. So all we are saying is that Laplace transform helps to solve differential equation. Okay, it is used to solve differential equation, where it is used to reduce a differential equation into an algebraic expression or an algebraic problem. Or we can also say that it is the integral transform of a given derivative function with real variable t. You see, so I was saying that the real variable here is t, which is then converted into a complex function with a variable s. Okay, so once we convert the real variable t into another variable, which is a complex function s, then we are doing what we call a Laplace transform. Okay, all right, so I guess you got that. So here we can say that f of s here, or f of t, is the same as the Laplace transform. And then we have s here, like I said earlier, is the complex number. And finally, t here is a real number greater or equal to what? 0. Okay, so now the last thing that I will introduce here is the derivative function of t. So here we have dt. Now dt here is the first derivative of the real number t. So let me put that one here. Alright, so there are various properties of Laplace transform, and these properties will determine its application. I will actually be talking about shifting property, but not in this video. So you can locate other videos under Laplace transforms in this playlist. So let's talk about Laplace transform of a function f of t equal to a, and we will end it there. Alright, so in the beginning we learned that the Laplace transform of a function f of t equal to f of t, that function given, times e minus st dt. Don't forget we are taking the integral of that, introducing our lower and then upper limit. So let's quote the formula. Now we know that the f of t is a. So all we need to do is to substitute a here. So our next step, the Laplace transform of a will be equal to integral of 0 up to infinity. We introduce our a times our e minus st dt. Now, before I will integrate the function, I will take you to how to integrate an exponential function. Okay, if you are watching this for the first time, if you haven't gone through my videos under exponential functions, let's assume you have an exponential function e to the power, let's say 2x. So the integral of this, when I want to integrate this, is simple. I'll just pick this variable and use it to divide. Okay, so the easiest method I usually use is to say that the integral of this is 1 over the coefficients of the variable you have here, 2, the same e to x. Do we get it? Okay, so every time 1 over that particular coefficient, then you raise it to the same power. This is how we integrate. For differentiation, you just use it to multiply the whole function. Okay, so let me take another example. Assuming I have e to the power, let's say a times t. So a here is standing for my value 2, which is the number 2. So when I want to integrate this, all I am going to do is that I'll pick 1 over a e to the power at. Do we get it? All right, so now when we look at the function we are coming to work on, we have e to the power negative what? St. So all we are doing is that the integral of this is going to give us 1 over neg s e to the power what? Neg s times t. And we are done. As simple as that. So let's introduce that. So now to integrate this, we will use the method that we learned, and then we introduce our lower and upper limit. So all we need to do is that this is equal to, now don't forget that we already have a variable a here. So this is my a times, now let me just write my 1 over negative s, then raised to the same e to the power minus s. Now I can use a shortcut method by removing this one and using this a to multiply. So the result will give us a over negative st. Now we just have to introduce our lower and then our upper limit. Okay, so we just put this side in bracket. I was supposed to do that, and then we introduce our 0 and then our infinity. So when we rewrite this equation, we are getting a times 1, which is the same as a all over negative s, then introduce your upper and lower limit, e minus st into bracket 0 infinity. Now we introduce the lower and the upper limit. Now remember that these lower and upper limits are real values, and this belongs to what? T. So from integration, all you need to do is that you introduce the upper limit minus the lower limit. Remember, upper limit minus the lower limit. So this is giving us, we have negative a over s. This is the same as negative a over s times, now let me introduce the upper limit, e to the power negative s into what? Infinity. Wherever I see t, I introduce the upper limit. Then I close the bracket, minus e negative s into what? 0, which is the lower limit. Now, when you introduce the infinity sign here, everything converges to 0, because as t approaches infinity, the Laplace transform tends to what? 0. So, but remember that anything raised to the power 0 is 1. So this side, we are getting what? Negative 1. So this is giving us negative a all over s times what? 0 minus what? Everything that we have here is what? 1. Remember, x to power 0 is 1. So if we have this raised to power 0, the result is still what? 1. Alright, so your next step is to use this to multiply this and use this to multiply that. So this is giving us negative a over s times 0 will give us 0. We don't want that. So that is out of the way, and negative a times negative 1 will give us what? A over what? S. And that is it. So the Laplace transform of a equal to what? A over what? S. So this means that anytime that you have been given a Laplace transform of a certain value, the result is what? That value over what? S. We get the concept. So for instance, if I give you the Laplace transform of 4, 2, 3, whatever value it is, all you need to do is to write that number over what? S. Because when we extend this, we can evaluate the following, which is L into 4 as 4 over S. So when I give you the Laplace transform of, let's say, 2 is giving us 2 over S. When I give you the Laplace transform of a negative number, for instance, Laplace transform of negative 5, the result is minus 5 over S. As simple as that. So I guess you got this. I just merged the Laplace transform of a function a, which can be any real value, into the introduction video so that you get the concept. Thank you very much. My name is Daniel. Please subscribe to this work. Please subscribe to this work. Support this work if this has been very useful to you. and I will see you in the next one.